So I was interested to make the Surge SSG, and this is Ken Stone's page, but he doesn't really talk much about how the circuit works. Just kind of gives an assembly instruction on his page, and I thought I'd talk a little bit about how it works. And I implemented it using op amps instead of LM3900 Norton amps. But so basically how it works, as I understand it, is you've got a single pole voltage controlled low pass filter right there, and that's basically straight out of the LM13700 data sheet. The difference being he doesn't have, instead of the Darlington pair for a buffer there, he's got sort of a unity gain buffer that looks like that, and that looks a little bit confusing, but basically it's straight out of the LM3900 app note. That's a different circuit, but so this is the circuit they give for unity gain DC buffer, and basically it's the same circuit he's got here, except he's got this JFET buffer on the input, and he's got this resistor on the output of the 3900. So what the JFET does is it greatly increases the input impedance of this buffer as a whole here. You need to do that because if there's any leakage at all into this buffer here, you're not going to be able to hold the circuit or freeze it where it's at when you're implementing your track and hold. But so that's kind of the heart of the circuit, and then there's a control voltage processing circuit here, which just basically non-invertingly gains the control voltage input for the rate or the time constant or speed or whatever you want to call it. And then there's a hold function, so when this gets a logic high, it turns this transistor on and it rails this guy low, and that turns off this transconductance amp. So the charge on this capacitor stays where it's at, and current can't go that way or that way, so you end up holding the voltage or sort of freezing it where it's at. And then on the output here, he just takes the output and feeds it into this comparator circuit, and that was a little bit inundating for me because I wasn't familiar with the Norton amps, but that also comes pretty much right out of the 3900 app note, except for, again, he has this little resistor in series with the output. So apparently that was a technique that either Sergey or Ken liked to do. But and then finally, that's basically the smooth side. And then to implement stepped, he just has a track and hold to sample and hold converter here, and all that does is it's normally high, so it's normally holding, and then when you get a logic rise, it pulses low real quick, so it samples it and then it goes back to holding it. So I implemented this circuit, or the SSG or whatever, using just straightforward op amps. Here's the filter core there, and instead of this complicated setup with the JFET and the Norton amp, I just used a unity gain buffer. But the caveat there is that you have to have a fed input op amp, or it won't hold. It'll drift when you implement the hold. And then for this Schmidt trigger there, I just implemented a really straightforward op amp Schmidt trigger, and changed up the control voltage processing a little bit. And this op amp here has to be rail to rail in order to turn this transconductance amp all the way off. One of the cool things about the 3900 is that it is rail to rail, so it was probably rare in 1973 or whatever when Sergey made this thing, so that's probably part of the reason he used the 3900 in the circuit. And then to implement the track and hold, the sample and hold, I simplified that circuit quite a bit. It's just an inverting op amp, so it's normally railed high according to this biasing right here. And then when you hit it with a rising edge, it pulses low real quick and then goes back to holding high. So here's the circuit. Got it going here. I've got two smooth sections going, and they're in cyclable mode. And so here's one of the sections going right there, and I'll adjust the control voltage right here. I'm going to adjust the frequency, and then to demo the track and hold, I'll just take I think it's this wire, and touch the positive rail. Nope, it's the wrong wire. So I'll take this wire here, yeah, so every time I touch the positive rail, it just freezes the circuit where it's at. And because it's using a rail-to-rail op-amp for the CV control, and it's got that nice JFET input for the buffer, you can hold it there and it'll just stay there. It won't go anywhere. So that's that. And then since I've got two of these, I'll turn the other one on. There's both of them going at the same time. So I'll patch the patch the hold from one, or the cycle output from one side to the hold input of the other side, and you can see it holds it automatically. And we'll get a little bit more of that going on. Patch the cycle of the one side to the other side again. And get a little bit more stair-steppy trapezoid stuff going on. And then you can modulate the frequency of one side with the output of the other side. So I'll implement that. As I increase that modulation, you can see the yellow line becomes less linear when it's sloping. And then I can go do the same with the blue line. So in real time you can see it's doing some interesting stuff. Those are the cycle outputs, and these are the outputs, the smooth outputs. So I'll change the time constants and stuff a little bit. There's another voltage control right there. But it's kind of cool. You can imagine in a modular context you could add a lot of cool autonomous randomness with this circuit. Like these could trigger envelopes and control a VCA or something. These control a filter or an oscillator or something. You can get all kinds of cool West Coast style stuff going on. So anyways, I'll probably demo this in a modular context in a bit. So here it is on the desk, and I thought I'd demo it in a patch. So I've got kind of a simple patch going on with the SSG as the only modulation source. Right now I have two smooth sides, and I'll probably patch in one as a step to get a stair-steppy thing going on, because it's kind of known to do that. And so one side is modulating the amount of wave folding going on, and it's also modulating the frequency of the VCO. And then the other side is modulating the cutoff frequency of the filter and the gain of the VCA. So pretty simple patch. And then I have a mixer that's scaling the control voltage going into the VCO and a multiples module. So let's see. 7 modules, I guess, in this patch, which is quite a bit, but I think it's a simple enough patch that you can pretty much directly see the SSG's involvement in it. So it's sort of a scratchy turntable patch. So here it is.